Thanks, Rosanna. Thanks for hanging out with me today to chat about MLOps and how to improve model accuracy. So I want to share with you some ideas that I've collected over the past year, and I hope that they will be useful to a lot of us in the AI community. And I would also get love to get some feedbacks on those ideas. So my name is Edouard Archambault, and I'm the CTO of Kili Technology. We are a leading data annotation platform, and we help our customers to scale with annotation of text, PDF, image, video, and audio data. As you probably know, as we probably all know, AI leaders such as Google, Facebook, Uber, Airbnb, and more have all developed platforms over the last few years to help them to industrialize the production of their machine learning. And those platforms are made of machine learning frameworks such as TensorFlow or PyTorch, orchestration tools such as Airflow or Kubeflow. But who among you has ever heard of Halo? So Halo, so little known component of these AI platforms is the annotation brick that is, however, at the heart of these platforms. And Halo is the annotation framework of Facebook. Indeed, when traditional software is made of code, is powered by code, AI is powered by data. And in fact, AI is made of three components. So the first one is the computing power, the CPU, GPU, and it's not a bottleneck because today it's widely available, scalable, thanks to the cloud, GPUs, and so on and so forth. It's also made of code, but it's a bit the same story, thanks to GitHub, thanks to open source, thanks to all the publications of academics, Google, Facebook, and so on and so forth. It's not really a bottleneck today. And last but not least, AI is made of data. And data, okay, there is a lot of it. Since the digital revolution, almost all the information in the world is recorded in the digital format. So meaning readable by a computer, usable by a computer. But to make it really usable for machine learning, it must be annotated. It must be structured. It's a bit the same story than for a diamond. Carbon, when it's not structured, it's graphite, it has no value. But when it's structured, it becomes a diamond, it has a lot of value. And it's the same for data with machine learning. Why? Because the approaches that work today, when you do machine learning, are mostly supervised one, where you need to have examples. And it works a bit like when you show examples to a child and you say, you saw a picture book and you say, okay, it's a car, it's a plane. It works the same. But despite this, many people, when they try to improve machine learning, they try to start to improve the code. But on many applications, it's much more effective to try to iterate and to improve the data. And for instance, but this is what Facebook does every day when they ask you to comment images or to tag faces. We upload more than 1 billion images on Facebook every day. And doing that, we build for them a huge training set. In the early years of Facebook, their researcher and machine learning teams created custom annotation tools from scratch. But as machine learning proliferated across teams, they wanted to scale this process, and they built Halo, allowing them to more easily and efficiently create, through annotation, high-quality training data. And at Google, you have almost the same story. It started in 2013 with the rebound of deep learning, and at that time, they were using the available workforce of Google Maps teams for annotation. So all of them, Amazon, Uber, Apple, Waymo, Lyft, all of them, they have their own annotation tool because they all have experienced that it's better to have a standard model on good quality data than a state-of-the-art model on bad quality data. So the data is more important than the model. And so at Kili, we help our clients to follow this path. So from being a model-centric way to develop machine learning to a more data-centric one. And so I will share with you some key takeaways. So the first one is that when you want to do this, what is key is to have consistent data. And consistent data, so high quality data is better than a lot of data. I will illustrate this with a small example. And the idea behind is that when your data is inconsistent, it's confusing for your machine learning algorithm, and it's going to hurt your performances. So because I love kitesurf, and I really like kitesurfing, I will have a kitesurfer detection example. But this example works for any object detection task in computer vision. So let's say we want to build a model to detect kitesurfers. What I will do is that I will go to the beach. I will take 1,000 pictures of kitesurfers, and I will send them to a labeling team, asking them to indicate on the pictures the position of the kitesurfers. And what I will get is from labeler 1 this output, so those bounding boxes. Labelers 2 will do this, annotating only the kites, and labeler 3 doing one bounding box for all the 4 kitesurfers. So it's a good job, but in fact, it's not good for me because those labeling conventions are not consistent, and it's going to hurt my machine learning performance. And in fact, at Kili, we computed that a 10% reduction in label accuracy typically results in a 2 to 5 decrease in model performance. So given that the sensitivity of a model performance to label quality and given also the resilience to training data size, we advocate at Kili that it's better to annotate less data, but with consensus. So being sure of the consistency of the annotation. And so what we do recommend is that data scientists first build their initial model with a few hundred labels per category to evaluate the sensitivity of the model to label quality and to the training data size before collecting more labels and annotating more labels. And because quality is at the very heart of data labeling, we do provide some tools to handle consistency. So the first one is instructions that are shared among annotators to make sure that they are aligned on the definition of good labels. Second feature is consensus and honeypot, so having KPIs, having metrics to compute the quality and the consistency of annotations. Consensus being having several people annotating the same data, and honeypot being having a truth that is given to annotators blindly and that they annotate to compute a metric. And last but not least, a bit like on GitHub or GitLab, we provide a workflow so that annotators can ask questions to reviewers, and reviewers can create issues on the job done by labelers. So consistency was the very first key and very first point when it comes to data quality. The second one is iterating on data. So AI systems, we said, are made of data and code, and the industry over the last few decades has progressed a lot, iterating on the models. And it's time to start iterating on the data, and to move away from really machine learning to machine teaching. And why? Let me illustrate this with a very small example, still on kitesurfing. So when I annotate my kitesurfers, I will have several kind of pictures. So kitesurfers doing a water start, a kitesurfer just so at the sunrise, a kitesurfer jumping, a kitesurfer just sailing, a kitesurfer saying hello, a kitesurfer falling down, a kitesurfer and two kitesurfers in the night. So for my model to perform well, all of these scenarios needs to be included in my training set. And so what matters is the way I design my dataset. And to take a toy example, if my baseline my baseline accuracy is at 70%, usually if I iterate on the model, I won't bring that much value. But if I iterate on the data, I can target 80 to 90 detection accuracy. And so this is the reason why very often, and it's not a reflex that we have, it's better to iterate on the data than on the model. And in fact, more than that, selecting smartly the right data to annotate is key to success. So to improve machine learning, in fact, you have to understand the qualitative, so the failure mode of your model, and to fix them by collecting more data, to cover more scenarios. And so what it means is that we need to altogether to move away from the concept of a data set, a training set, towards the concept of a collection of scenarios that we need to build on the use case. And so to target those challenges, within Kili, we provide tools but to help you and to help the community to visualize the data and to search through it so using quality metrics, searching through the labels, searching through model inferences, searching through metric of the performance of a model against annotations, so that you can really select the data that matters to be included smartly in your training set. And the third point that I want to mention is that it's better to have a small model but retrained regularly than a bigger model that is static. When a model is trained, usually it's done on historical data, and but we need to make sure that the model will continue to work well in the future. And so to do that, it's critical to be able to monitor the predictions, and so that we are sure that the model is still accurate. To continue with my kitesurfing example, the kitesurf was invented almost 20 years ago, and it has evolved a lot since then. The board, at the very beginning, it was a surf board, then twin tips, And today, people use foils. And the kites as well have evolved. At the very beginning, it was delta kites. And today, it's those C-shaped kites. And so if I had developed a model a few years ago, when foils did not exist, it probably won't work very well today to detect this kite surfer, for instance. And so to address this, what is key is to be able to log the predictions from the production model and to hold back a percentage of those predictions to push them to database so that they can be annotated and so that we can compute regularly the model accuracy to be able to detect a concept or a data drift. So to do this, we try to design Kili. So we design Kili as an API first platform so that it can fit in a model infrastructure, in a machine learning infrastructure, and can be integrated deeply with the upstream data storage and the downstream machine learning framework. And so when going into production, but you can already orchestrate the lifecycle management of your model. You can monitor from the production flow predictions. You can extract them and send them back to annotation. And so it's very valuable to be able to fight any drifts. So to sum up, why I try to share with you is that there is kind of a machine learning secret sauce that is made of three components. The first one is that so annotation consistency is really important, and so to tackle it, but we need to check that when we label data, labelers are annotating in the same way. And so we need metrics to do this. And if we don't, so this lack of consistency is going to deteriorate the model. And usually it's less expensive to annotate with consensus than to annotate more data. The second part of the secret sauce is that there is a lot of value to be, and it's usually easier to iterate on the data than on the model. And so there is more value to be extracted and more performance to be extracted from iterating on the composition of the data set. And until now, we didn't have tools to really do it, to visualize the data and to search through all the metadata linked to my data. And so at Kili, we start sharing those kind of tools. And last but not least, when you go to production, the job is not finished, but you need to have this feedback loop from production to the training set, so to continue to annotate and to have insights on if the model is still accurate or not. So thanks a lot. I hope that that those few words and those few ideas will be useful to you, and happy to take some questions.